Hello, this is Nitin Dahad with the Times, and I'm here with one of today's, the speakers at HiPEAC 2026 in Krakow in Poland, Pawel Skruch. Hello, Pawel. How are you?
Thank you. I'm fine. How are you?
Good. Now, tell me, you used to work with Automotive. You've had some industry experience. Now you're at the university here locally?
Yes. I am representing here the university, AGH University of Krakow. So this talk, what I presented today, was rather from the research perspective. However, some industry experience was also included in this talk.
I mean, I have to say yours was probably the most fascinating talk for me of the conference. So thank you for that. But
okay.
Let's backtrack a little bit. You've presented on Monday on some of the work you're doing, and then today you presented about, I guess, what needs to be thought about in the software-defined vehicle journey.
Yeah.
But just give me a little broad perspective of the work you do.
From my experience, I am focusing on some control engineering aspects, with applications of robotic systems. So my research background and expertise is related to the robotic systems, and the vehicle can be considered as one of the, most complicated robot in the world. So that is fascinating for me.
Well, especially, I mean, I've traveled in Waymo in the US, and that's kind of one of those robotic systems, isn't it?
Yeah, exactly. So this was amazing. And what surprised me very much in looking at how these autonomous vehicles are operating on the real world conditions, that, at the beginning you are scared a little bit if you see such a robotic system near to you, which can be also considered as a safety critical system. But the day after, so you are familiar with that, and you can easily adapt to the situation and consider this as a normal behavior. So.
Okay, let's just give me a bit of summary of what you presented on Monday, and then we'll talk about the software-defined vehicles that we talked about today.
Yeah, on Monday we presented together with my colleague. We presented the results of our European-funded project, Code for EV, and the main objectives of this project is to demonstrate how software-defined vehicles can be beneficial from the practical user experience perspective.
And was that very similar to what we've been hearing from the whole industry? The chip industry, the OEMs, about how it can provide benefits to consumers in terms of what they can buy as a service.
Yeah, exactly. So this is exactly the same approach, the service-oriented approach. So this is one of the pillars in Industry 4.0. So definitely.
And now today, let's come to today, because what I found fascinating is the journey you presented in terms of the car of the 50s and the car of the 2020s, and I think your point that you were trying to make is, don't forget the physical side of whatever it is. It might be software-defined vehicles, robots. There's so much that's still the hardware. And you talked about the wiring harnesses and how they just have grown. Just give me a little picture of what you're trying to get over there.
Yeah, so because we are talking about the software, so everybody is fascinating about the software and what software can do. Yeah. But we should not forget that software must be executed somewhere.
Yeah.
So and this somewhere means that there is right execution hardware platform. Yeah. So if there will be no support from the hardware perspective, so we will not be able to apply some software-based solution in the vehicles, for example, in the robotic system.
Yeah.
So I think this is the same important as software, even if a majority of the effort is put into the software. However, hardware is a skeleton.
Yeah. I mean, you showed an exploded diagram of all the mechanical components that go into. I think that was only the IVI system, but still. Yeah. And then there's a little PCB there, and you said, like, you've got all of this, but 90% of the effort goes in that. On the software for that electronics.
Exactly. That's fascinating. It's also fascinating me that there is small pieces even invisible from the user perspective, but the power is actually with the software in terms of the functionalities. Probably.
Now, the other thing you said is a lot of what we're seeing on the roads today are still not even that zonal architectures. I mean, we'll see them maybe in the later 2020s. So what are people mostly driving around today?
So right now, majority of the cars or vehicles that are on the road still rely on the domain or distributed control architecture.
Yeah.
So this is very reliable and over the couple of last decades proven solution. But because of the higher demand right now that is imposed by incorporating sophisticated high resolution sensors like vision cameras and lidars, so we need also a change in the vehicle architecture. So that's the reason, or one of the driving forces towards new architectures.
Yeah, so I think what you showed a little bit of an evolution now from the central domain, so centralized CPU or domain, and then the zones. But then you talked about moving that to a serverized domain.
Yeah.
What did you mean by all of that?
So sooner or later, so vehicles can be, in my opinion, from the research perspective, considered as servers on the wheels.
Okay. Yes. Yeah.
So we have as a research and technological community big experience and with the serverization. So a lot of applications are running on some servers. So this approach is good from many reasons. So natural path is to also apply this to the software, having into account the perspective that more and more functionality is expected from such robotic systems.
And the other point I think you made is the amount of software code on some of the premium vehicles right now, like 100 million lines of code, and you compared that with other things in our lives, like Meta or Facebook or I don't know, a couple of other things, or aircraft. It's quite significant now, isn't it, in terms of the code on? It's probably the most complex software system in our lives. Is that right?
Yeah, definitely. I agree, but we should not forget that more software means more errors.
Yes.
So one of the aspects important is to consider is that if we write more software, we should also think about how to verify this software properly in order to avoid potential mistakes.
Yeah.
So this is not like that we add more and more software and yeah.
But if you go serverized, and if you go you showed the Alpamayo, if you go all that route, you will need all that code, won't you?
Yeah, definitely. So there is no other way. I think that we should expect more and more code.
And now with the Nvidia Alpamayo, I don't know, the reference, the model. You said the big challenge right now for the OEMs is not using it; it's actually getting it into production scale. Is that right?
Yeah, exactly. Because
what are the challenges there?
There are a couple of challenges. In general, when it comes to the making the product or making the series production vehicles or series production robotic system, we have to operate under several constraints. And one of the biggest one is definitely energy constraints, because also there is limited amount of energy, and right now everybody is looking for some energy efficient solutions. So this is one. The second one is safety, because we are operating the safety critical system, so it's important. And cybersecurity, another topic which is a key topic for the entire conference. Yeah, definitely. There are other like reliability. What else? Thermal energy dissipation.
Yes.
Because if you have graphic cards, usually this graphic card produces a lot of energy, and this energy should be somehow dissipated. If you have the server in the air conditioning room, that's okay, but in the car we have not such environment. So we need to find out about the good solution, how to dissipate this energy, or to optimize the overall system in terms of the energy consumption.
And I think one of the messages I got from you is we're going towards that software-defined route, but there are things to be wary of. So what are your top things that you think you need to be wary?
Yeah, so this energy optimization, so definitely removing or making this system reliable as much as possible. because every software contains errors. So this is known from in software engineering industry or discipline for many years.
Yeah.
So we should make sure that there will be right methods applied to such system to make sure that the system contains as much as possible the errors. Also, we should somehow prove the safety of such systems.
Okay.
Because 100% safety is never possible by definition.
Yeah.
So we need to have some confidence level that the system is safe enough for us as a society or final users.
And the other thing you were talking about is like the need to move towards open source. Is that right?
Yeah. So I was always fan of the open source because mainly of the number of people that are involved or contribute to such systems. So there are, of course, some consequences, because if there is open source, so everybody has access. So there is some potential cyber physical cyber security attacks possible, because everybody knows the weaknesses of such. So we need to also take these open source solutions with special care and making sure that the system is reliable enough.
One of the interesting questions in your session, after your session, was from somebody who asked whether you can run the software-defined vehicle on a traditional ICE engine, and I think your answer was yes.
Yes.
But the way things are going is electric.
Yeah, so this is, I think, the general trend to have, energy efficient solutions and also, eco-friendly solutions. So this is some trends. So I think this is a natural path to put more effort on the electric based system than traditional. But from the technical perspective, from my point of view, this is not the big issue to move from one moving platform to another. The same is for the robotic system.
Okay. So, well, Pawel, thank you very much.
Thank you very much.
Thank you.